So, good. Actually, this is the topic that I really want to talk about here. This is the thing that I have more or less spent all my life with. Since a 6-year-old kid, I'm now 38. 32 years, I every day somehow interact with computer with a vision of the future, with an idea of how much more we could do with the computers. Computing is broken. And it's not because of the hardware. It's because of this guy. Because no matter how nerdy, how geeky, even if you never did anything except program, there is no way you can deal with even a small fraction of the true complexity of this. A modern processor does 2-3 billion clock cycles a second. Every second the clock ticks 2-3 billion times. And at every single cycle, a 64-bit block goes through. This is in optimal conditions. So, anybody want to take a stab how many zeros are on the universe of variety that 64-bit block represents? Anybody? I think it's about a trillion. It's somewhere there, but it's big. So why computing is really important and why I am clearly very affectionate about this topic is not because of data modeling, it's because of computers. So I believe, and I think a lot of other people believe, and I believe that most of you will believe it as well, that advancements in computing will benefit advancements in science. A lot of the significant research, dark matter, evolutionary biology, a lot of these different things, they depend on computing. And you go to any research facility, including here, the supercomputers are fully booked. And you go to ask from any research agent, do you have enough supercomputing time? None of them have enough well, some, there are exceptions. But most of them will say, no, I'd love to have more. Actually, this is slowing down our research. And what's really cool here, that they really work together. Computing efficiency improves advancements in science. And then advancements in science improve computing efficiency, or have the propensity to act as a cause. So it is just this self-enforcing cycle. I wanted to say vicious cycle, but it is really, I believe, for the greater good of humanity, so I think that would be a bad word. So how about if we step it up a notch, or a few notch, and then remember again, this is not a zero-sum game. Most of our resources, most of the smart people, they play the stock market, they play marketing, they do all these different things that are all zero-sum games. So basically, two smart people play against each other. How about if these smart people play positive-sum games? Games that they can both win in without the other losing. But instead of talking about this, we talk about big data. Everyone's having the big data Kool-Aid. And why? It's because the big IT and the big consultancy, they're very good at getting people to drink Kool-Aid. Whatever Kool-Aid they want people to drink. In the 1990s, it was integration. At some point, 95 of all IT budgets were going to integration. Then 5 years later, you went to these big corporates and it was a huge mess. So they show us slides like this. It's going to be trillion devices and blah, 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 blah. And everybody's drinking the Kool-Aid. Why don't they show us this kind of slides? They like to show us maybe the top part that the Moore's law is going up. Yeah, the transistors are coming denser and denser and denser. But what they forget to tell us that there's another law that has gone together with Moore's law, which is no longer going together with Moore's law, which correlates with actual throughput, which correlates with actual computational efficiency.